When a single text prompt can produce 30 seconds of film, complete with synchronized sound, that is not a toy anymore. That is a production tool. This is Seedance 2.5 from ByteDance, the video model that officially launched on July 31st, 2026. It is built on a unified audio-video architecture that generates picture and sound together in one pass. But here is the bigger story. The makers of these models say the expectation has shifted. People no longer want a random clip. They want a completed creative work. That shift from generating a fragment to finishing a story is exactly what Seedance 2.5 was built to answer. So in this video, we will break down how Seedance actually works under the hood, what hardware and infrastructure it needs, and why it has the video world paying attention. Before we go under the hood, understand the problem Seedance is trying to solve. Most video models give you short clips, 4 seconds, maybe 8. That is enough for a reaction or a loop, but not for a scene. To make anything longer, you stitch clips together and the stitching shows. Cuts break, characters change, the physics reset. For anything with a narrative beat, like a commercial or a story, that is a deal breaker. Seedance 2.5 changes the unit of work. It generates up to 30 seconds natively in a single pass. Why does 30 seconds matter? Because that is the length of a typical ad, a social media moment, a single coherent story beat. It is the difference between producing a clip and completing a shot. And when a model can hold a coherent scene for 30 seconds, it stops being a novelty and starts being a camera. So how does the model actually turn words into moving pictures? Like most modern video models, Seedance is a diffusion model, and the whole process runs in a compressed space called latent space. Here's the pipeline. Your text prompt is converted into embeddings, which the model can understand. Raw video, which is enormous, is compressed down by a variational autoencoder, or VAE, into a small latent representation. That latent space is then chopped into little patches, the same way a vision transformer splits an image into tokens. Those tokens become a sequence the transformer can process. Then the generation loop starts. The model begins with pure random noise in that latent space. And over many steps, a transformer network learns to predict and subtract the noise, slowly revealing a clean, coherent video. When the loop is done, the latent is decoded back into full frames. That is the skeleton of every diffusion video model, and Seedance is built on top of it. Now, the engine that does the heavy lifting is called a diffusion transformer, or DITE for short. This is the architecture that replaced the older UNet designs, and it is what powers Sora, Kling, and Seedance. The key idea is that every patch in the latent space becomes a token, and the transformer runs attention across all of them at once. But video is not just a flat image, it is 3 dimensions: width, height, and time. So the attention is 3-dimensional. It tracks how each patch relates to its neighbors in space, and how it changes across time. That is what keeps motion consistent. So a hand does not teleport between frames. The denoising happens in steps, and each step the transformer looks at the current noisy latent, the time step, and the text conditioning, and predicts how to clean it. Optimized versions use far fewer steps, trading a little quality for speed. The more steps, the sharper and more coherent the result. Here is where Seedance separates itself. Version 2.0 introduced what is called a dual-branch diffusion transformer. Instead of one network generating video and another generating audio and hoping they line up, Seedance runs 2 coupled transformer branches side by side. One branch denoises the video stream. The other denoises the audio stream, and they are synchronized at every generation step inside a single forward pass. Because the audio branch is coupled to the same timstem as the video branch, the sound is locked to the picture at a millisecond level. Dialogue, footsteps, ambient wind, all generated natively and aligned with the frames. No secondary post-production sync required. This is why Seedance sounds different. The audio is not a band-aid added afterward. It is generated as part of the same creative act as the picture. Gray generation is only half the story. The other half is control. Seedance 2.5 is built for what is called reference-based generation. It accepts text, of course, but also up to 30 images, 10 videos, and 10 audio clips as references. These references ground the output, so a character looks the same from one scene to the next. The environment stays consistent. The camera behaves as you asked. This is how you hold a face or a location, or a style across 30 seconds instead of hoping it survives. There is also region-level editing, where you can select a part of the frame, tell the model to change just that, and the rest stays untouched. Add up to 50 multimodal references, and you are not prompting a generator anymore. You are directing a scene. That is the difference between typing a wish and composing a shot. So what does Seedance need to run? For most people, the answer is nothing special, because Seedance is delivered as a managed cloud service through the Volcano engine and through ByteDance surfaces like Emung, Gemina, and CapCut. You do not need a local GPU to use it. A browser and an internet connection are enough because the heavy compute lives in the data center. If you are doing local staging, preparing high-resolution assets, or running workflows in tools like Comfy UI, then you want serious hardware. At least 16 gigabytes of VRAM and fast NVMe storage to move those large reference files around. As for what it took to train the thing, that is another order of magnitude entirely. Thousands of GPUs for months. The cloud abstraction is exactly why a model this heavy can feel so accessible on the other end. Now the payoff! Why is Seedance considered so good? Stack the wins. Native 30-second single-pass generation so it can complete a coherent scene instead of a fragment. Up to 4K resolution, which is a professional deliverable, not a thumbnail. Native synchronized audio generated with the picture, not bolted on later. And a world model with real physics, so fluids flow, cloth drapes, and crowds move with believable mass and momentum. Together, these add up to long-form narrative consistency, the thing that has historically been the hardest problem in AI video. That is why the industry is paying attention, not because it makes pretty clips, but because it is built to survive the demands of an actual production, from a 30-second ad to a sequence inside a film. Now the practical side, the cost. And here is the honest picture. As of right now, ByteDance has not published official per-second API pricing for Seedance 2.5. The consumer surfaces like Emung and Gemina offer free daily credits when you start, and then paid tiers. Industry analysts estimate that a 30-second clip through the API could run anywhere from about $3.60 to $15 per generation. But those numbers are estimates, not official rates. The broader point is what this does to production economics. When a shot that once cost a full crew, a location, and a day of shooting can be generated for pocket change, the cost structure of video production changes. That is the economic disruption underneath the technical one. And it is why studios and agencies are watching Seedance and its rivals so closely. Let us pull it together. Seedance turns text into video by compressing frames into a latent space, chopping that space into tokens, and running a diffusion transformer that denoises random noise into a coherent scene step by step. Its secret weapon is the dual branch design, which generates synchronized audio in the same pass as the video. It needs very little from you on the client side, because the compute lives in the cloud. And it is good because it delivers 30-second 4K physics-aware, audio-synced storytelling that can hold a narrative together. The through line is control, references, region editing, long-form consistency. Seedance is not just another generator. It is the model that moved AI video from making clips to finishing shots. And that is why it matters.